be on your way. I ask also for your sympathy here because if you don't do anything, you get engineered. So my job here is to convince you to do nothing. To the extent that I'm here to promote engineering, and I'm really not. I'm really not here to push a particular major, but maybe to explain a little bit why things have been for the last few years, the courses that they have been, which is we're now calling a major, but it used to just be MSC's curriculum. Now it's got a name. Now it's being called a major. So okay, so be it. I'm going to start briefly with myself as a case study. I'm 45 years old. I've been a teacher of adolescents for 15 years. And for 6 years before that, I was a product designer, mechanical engineer, and entrepreneur in Silicon Valley. Brief stint as a lecturer adjunct at Stanford, master's degree there, art school, also in California, and a 4-year engineering degree, mechanical engineering, at Clarkson University here in New York. When I was 17, I was absolutely convinced that I wanted to be an engineer, that I wanted to make and invent things. And I went to a school which prepared me to be absolutely an engineer and nothing else, Clarkson. That's not the way my life went. I'm now a communicator, I'm a counselor, I am, I coach, so I'm somewhat, sometimes a parent even, for brief moments, they want this guidance. And my undergraduate education provided me no preparation for most of my job, okay? And I want you to think about a little bit, now that's undergraduate in college. I ask people to think about what is the purpose of high school. Is it to become incredibly good at one thing? I think even college is maybe not the time to become incredibly good at one thing. I have taught for 8 years at a math, science, technology high school in the city of San Francisco, which did amazing things with kids. And I teach at this astonishing institution with really smart faculty and great colleagues. And I feel, that talking here, I'm somehow drawing into question the value of having kids working with neuroscientists, or learning, things about set theory. These are things that are all astonishing and wonderful, and it's great to see the kids' enthusiasm. But I think as a parent, you have to say, is this the time for my child to become really good at one thing? And is this the time my child wants to do this one thing and he's really good at it, he should do more of what he's good at and not take art classes or not take astronomy or not play in the band because there's one thing they're really good at and I'm going to make sure they get as much of that as possible. This is a value judgment. There are definitely kids who are astonishingly broad-based in their talents and skills, who have a passion. And there's nothing more amazing than an adolescent with a passion. You want to feed that like a fire. But there are other kids who just, are developing and don't know much about the visual world, or know much about the musical world, or know much about writing. And I say push them to do more of that. Now, of course, none of these alternatives that have been that have been mentioned would in any way affect their humanity, so let me not pretend to say that. But I will say that engineering, which is, I guess, being presented as one of the 3 options, is the broadest of the choices that you have before you. And I'll also say another thing which sometimes surprises people. Remember, I'm the guy with the master's from Stanford in engineering. We don't teach engineering here. We don't, and we shouldn't, and we won't, and I wouldn't teach it at school. It teaches what I learned at Clarkson or at Stanford to adolescents, because I don't think it's appropriate. Half of my students in my junior class, about half of them are interested in something that's in the name of the school. Math, science, engineering, and architecture. The other half are just going to be citizens. They're going to be citizens in this city, which is the most engineered living environment on the planet, save maybe Tokyo. They're going to be citizens in the 21st century, where they have to be adept regardless of whether they are poets or neuroscientists or mathematicians. They have to be really familiar with technology. And in my engineering classes, we can't call them shop classes because, well, we don't use bandsaws, and that's just not cool anymore. But, you know, I have kids making things out of wood, and you might have made this in shop class 40 years ago. But we do this, we analyze it on a computer a little bit, and we test it with this computerized testing equipment, and they do some mathematical analysis of the forces. That's all great. You wouldn't do that in shop. But we don't really learn engineering because it's way too mathematical. It's extremely pre-professional. Engineering school undergrad is to prepare you for a job called being an engineer when you're 21. It's not a broad-based, here's what the world is. What we do here at MSC is, we're really trying to help kids understand that all the gadgets that they love, and you know, here I have a cool gadget if you want to see one, like how does this affect humanity? How does this make people communicate better? You know, how does it help them live their lives better? You know, I've got cell phones here. I have a class where we learn about products and technology and how they affect people. That's a really unique, broadening class. It's not about how to design a cell phone. It's really about what does this thing do to people. The seniors who stay in the engineering option, you know, there's an advanced architecture elective, which we will, this is, you know, the Chrysler building here. Mm-hmm. This is not a student work, but, you know, indicative of something that is beautiful, is a landmark for our city, houses people, helps them live their lives. And those are things that they will study if they want to do the senior engineering, sorry, the senior advanced architecture elective. And there is Mr. Yanakis's computer engineering class. I like that description of it because they learn about computer networks, and they also learn about flash programming and other ways of presenting multimedia on the web. And then the junior class is the digital electronics class, for which I brought a motherboard here. You know, most of our lives are run by these little pieces of fiberglass and silicon. And you know, I want you to think about, is this something that, you know, your child should know what these little black things are and what goes in them and how many hundreds of people it took to design that one at the Intel Corporation in, you know, Santa Clara, California. Is that something that's important, even if they don't necessarily ever program one of these? They're going to use one the rest of their life. They're going to be slaves to this machine. And if it's a mysterious black box, or if it's something that they can understand a little, will make a big difference in how comfortable they are with technology. So when we say that we teach engineering, I really would say more broadly we prepare kids to live in an engineered world. And whether they are practitioners, or we've got 5 or 6, I've lost track, actual engineers who work here like me, so they have that in the career angle. But even for the poets, and for the, you know, the doctors, and for the English teachers amongst us, they also will have some preparation for what they're going to do. So just, you know, I'll make the case for the broad, and make the case that whatever path that they take, you know, we'll do the best to get them ready for the world. So I'll take any questions if you had specific ones, and I know there were a few. That's all into my speech.